go ahead and get started. My name is Carly. I am part of the marketing and events department, and I help with all the webinars and everything. During this webinar, we just highly encourage you to take as many notes as you can. I know we're going to cover a lot of things, so if you need to look back on it or have any questions, feel free to go ahead and put them in the questions and chat section, or you can watch the webinar after we've recorded it on our YouTube channel. You can go to our Intertech University page, and there should be a button there that says Online Video Library that you can go and see all of our previous recordings as well as the one that we're doing today. The questions that you submit today, we will go over them either during the webinar or at the very end. So if you don't hear yours right away, just go ahead and wait till the end. And then we encourage you to ask as many questions as you can. Like I said, this is hard learning from it from a webinar point of view rather than being here in person and learning it. So we encourage all the questions that you guys have. And after that, we can go ahead and start.
Thanks, Carly. My name is John Pendleton, and I'm your trainer today. We've also got Kyle Smith with us. He's on the next slide here. But if you need anything, a PDF of this training or anything like that, training requests, you can certainly shoot me an email or give me a call, and we can get you taken care of. Again, John Pendleton. I'm senior trainer / technical support. I've been with Intertech for a little over 7 years now. I started out in tech support and kind of transitioned to the training this year. So obviously with all this virus stuff going on, we're kind of social distancing, and so I'm working from home, working a lot on these webinars and trainings and stuff. So I do have other trainings available. So if you go to our secure site and you look at those videos, you can also click on there and see any upcoming trainings. And obviously this is part 3 of a 6-part series. And but we also have geothermal trainings. I think I had a lockout board training on Tuesday. We've got an ECM board training tomorrow, and then some more geothermal trainings next week. And we'll add more and more as time goes on. So keep updated on that on our Intertech University site. Kyle Smith will be helping me out today. He's our solar sales and energy storage manager. And there's his email address, which is probably the best way to get a hold of him. He works out in the field quite a bit. Matter of fact, Carly and myself and Kyle were all out on a job yesterday afternoon on a roof mount. So getting some hands-on experience there. So it was nice to, you know, kind of see something in person when I'm training on it. So it's kind of nice to get out in the field yesterday with him. We do have a design team that can help you out with all this solar. If you sat through any of our other trainings, you've seen this slide before. But we just like to, you know, let you know what is available for you. So you can always contact design service. Email is probably the best way as well. So if you have a design you want, you can send it in to designservices@intertechusa.com. We also offer sales help, training on site. You know, sometimes we will come to the site and help you on your first install, just depending. Obviously, we offer training. We have marketing assistance as well. And if you ever need customer service, you can contact them for any parts or anything like that. You can always call them. This is the direct number to customer service. That's 618-664-9011. And you can certainly email them as well. We have tech support help as well. You can call, you can email technical services at intertechgeo.com, or you can definitely give us a call. And we'll offer some support for technical support as well. We have residential and light commercial solar arrays. Depending, we do have job site delivery. Your utility services will give you a hand on some of that stuff. You know, checking with the local utilities or co-ops and seeing what kind of incentives are out there. We may even speak with your territory manager who maybe has some a relationship with the co-op in that area and may know some of the opportunities out there for the solar. We'll obviously help you design roof and ground mounts. We're going to cover ground mounts today. Installation support, again, training and design services. So we're going to cover basically the performed products today and the Iron Ridge. They're the most common that we use. There's others out there. There's so many racking systems out there. If there's a racking system, you know, that you prefer one over the other, we can definitely, you know, if you prefer Iron Ridge over Perform line products, that's fine. If you want to use advanced racking, you definitely can. We have Perform line products, advanced racking, Iron Ridge, and Unirack is what we kind of use. We're going to focus today on the Iron Ridge and the Perform line products. If we were to cover all of these today, we'd probably be in here all an 8-hour webinar, and that's no fun for anybody. So we'll start out with the Iron Ridge. Let me go back to this first slide. One thing you will notice, if you look at the far left on the Perform line products, that is a single post, considered a strong back. And the Iron Ridge, you can see it uses a post, appears in the back and in the front. So it would have 4 piers, where the Perform line product only has, in this array here, it has 4, but it doesn't have any front piers. So it's all relying basically on that diagonal piece and then the strong back. We'll start out with the Iron Ridge. The Iron Ridge is nice because it's flexible. It can be mounted on any terrain, multiple array configurations. It'll work with a variety of foundation options, including concrete piers or driven piles. So you don't even have to necessarily dig holes. You could actually drive them into the ground, or you can dig a hole and put it in concrete as well. Normally, the Iron Ridge is compatible with the soil class 2 through 4. It's steel and aluminum components. There's no drilling, welding, or machinery needed. So you just have to have some torque wrenches and things like that. It does have a 25-year warranty. Iron Ridge will offer some design assistance online software, so you can visit ironridge.com and check out their online assistant. Or you can definitely contact us, and we'll get some information and help you figure out the setup for it. The one thing about the Iron Ridge is it uses rails that are locally sourced. So it'll use steel pipe in order to save on your shipping costs. You know, you could spend $2,000–3,000 just on shipping if you want to ship rails. So this option gives you the benefit of getting your 2 or 3 inch Schedule 40 pipe locally. Some of the components of the Iron Ridge, you will have the rails. These are the XR rails. Basically increases the structural strength and the spanning capacity. We have bonding splices. So if you've got, you need to put 2 rails together, you would use the bonding splice. The UFO and stopper sleeves, those are basically mid clamps as well as end clamps. It's a mid clamp if you don't use the sleeve. If you use a sleeve, it's considered an end clamp. Basically, these hold down the modules to the racking. We do have the top caps. It basically supports the cross pipe with the U-bolt hardware on your piers. You got your rail connectors, which attaches and bonds the horizontal cross pipes. The Camo is basically a clamp, an end clamp. But on a ground mount, if you want to make it look kind of pretty, you can use these. This is another version of the end clamps. So you can actually use what they call a Camo, and it'll kind of hide the clamp. And we'll cover that Camo a little bit later on, further down in the training. Some of the other hardware it's showing here, make sure we've got some grounding lugs that they'll slide right onto the rails and mount to the railing system itself. And we got to make sure we ground that system. There's also a diagonal cross brace, which is a kit that's optional. And it just depends on how many panels in your array and what's going on up as far as support is needed. So you may or may not need that extra support. So again, the locally sourced 2 and 3 inch Schedule 40 pipe, and you can also use some mechanical tubing, saves on freight, while still being able to span up to 18 foot on a vertical pier. So here's a little bit of the specs for the piping. It's 3 inch pipe. It's got a 3.5 inch OD. It's got a 0.216 wall thickness and 35 KSI yield strength. And then there's the 2 inch, and then you get into your mechanical tubing as well. This is a span and pipe chart. It's in the installation manual, so you can look in and see the type of pipe and the span that you can go up to. So you can kind of look at this chart, and we'll definitely take this into consideration when we're helping you design some of this. So we will look at this span chart to see what kind of spanning we can do with 2 inch or 3 inch, depending on the pipe, the tilt, the height, all that kind of stuff. So some of the tools that are going to be required for the iron ridge is a post hole digger or a power auger, a socket drive with a 7/16, a 1/2 inch, and a 9/16 socket. I'd probably prefer, or you probably want those to be a deep well socket. If you use a shallow well, sometimes it won't, when you tighten it up, it won't go all the way down because it'll bottom out. So usually use a deep well socket. Torque wrench, 0 to 240 inch-pounds and 10 to 40 foot-pounds torque wrenches. Laser level, a string line, and a transit, and also a 3/16 inch Allen head. I would probably maybe get a maybe an impact or something as well, and put it on your low setting. Some torque values, I'm not really going to harp on these too much. I just wanted you to see that there are different torque specs depending on the part or the pipe. So this is all listed in the install manual, and so I'm not going to go over every single one of them. I don't expect you to remember all this because I'm not going to. So a lot of times I'll just carry the sheet with me when I'm out on a job, so I know where we should be torquing these values to. So the first step that we're going to do when we start building this racking system is you're going to obviously establish your pier locations. Make sure that you don't have any obstructions or trees in the way, things like that. And then once the grid of piers has been set, you're going to have to make sure that all the angles are square. Spacing is going to vary by load conditions. So, you're going to have to check your engineering specs, look at that pipe span chart, and consult with us on pier locations. So you can dig the foundation holes and insert the vertical piers into the holes and pour concrete. You can also drive them into the ground. You may be a little bit careful when you're driving into the ground with I-beams or posts. If you hit rock, it will bend them, and then they're kind of trash. So if you have really heavy rocky soil, it's probably not going to be the best to pound those in. You're probably going to have to auger it out, dig it out, something like that. Again, if you're digging it out, you can make sure you're pouring concrete in the foundation. Obviously, make sure that the piers are in 90 degrees. Make sure they're plumb, level, and square, as well as placed in parallel rows with each other. I mean, it seems kind of obvious, but you never know. So we just, make sure that they're in line and they're all square and level and all that. Make sure the top is level as well with each other, because obviously we're going to be putting a top rail on there. In some cases, the cross bracing is required to provide extra support. If it is required, you're going to install the diagonal cross braces after you've gotten your piers in position. Next thing we're going to do is we're going to connect the structure. So on the piers, we're going to mount the top caps. And so you just basically set them on there, put the screws in the holes, and wait to tighten them up. Because next we're going to go ahead and lay the cross pipe. So in that second picture, you can see the cross pipe laying across that clamp. There's a little bit of a groove in that top cap for that pipe to kind of rest in. So set it in that top cap groove and attach the 3/8 U-bolt flange nuts, the flat, and lock washers on there as well. Torque the U-bolts to 15 foot-pounds and align the assembly, and then you can go ahead and torque your top cap set screw for the Schedule 40 pipe. Next, we're going to place the rails onto the pipe. So go ahead and attach the hardware on the ground, attach the rail connector bracket to the rail by sliding the 3/8 number 16 bonding bolt into the slot. It is kind of like a rectangle head, so it'll slide in that slot, and then once you start to turn the bolt, it'll flip it, and then it won't, pull back out. Space out to match the pier spacings on your railing, and finger tighten the flange nuts onto the bolts. You might want to also tape the ends of the rail to keep the bolts from sliding out when you're moving them. You're spacing them out. Go ahead and fasten your connectors. So the center rails on the cross pipes, make sure you leave equal distance on the ends. Secure with your U-bolt, the flange nuts, the flat and lock washers as well. And those are going to go to 60 inches of inch-pounds, sorry. And the brackets are at 21. Again, I don't expect you to remember the torque values, but they are listed in the install manual that you will receive. Excuse me. Secure the lug. Make sure we're always grounding the racking. So there is a T-bolt grounding post lug fitting there. And you're gonna torque that hex nut to 80 inch-pounds. Install a minimum of 10 gauge solid copper or stranded wire. That little grounding block is made for a minimum of 10. Torque the terminal screw to 20 inch-pounds. That's your grounding screw there. There's only one grounding lug required per continuous sub-array, regardless of size. And also the grounding lugs can be installed anywhere along the rail. Again, the grounding lugs are designed for a solid or a stranded wire at minimum of 10 gauge. Next, we're going to go ahead, after we've got all our rails, our posts and all that are all square set, we're going to start securing the modules to the railing themselves. It's really a pretty simple process once you get the first one in and squared up. They'll all kind of fall in line pretty quickly. And it's kind of nice when you start getting the panels onto the racking, because you really feel like you've started to accomplish something, because you start to, see what it's all going to look at. Once you get all these panels up there, it's a satisfying feeling. Basically, you're going to secure the first end. So place the first module in position on the rails, a minimum of 1 inch from the rail end. You're going to snap the stopper sleeve onto the UFO. So that would be basically like an end clamp. You're making that UFO, which is considered a universal fastening object, into an end clamp. And make sure that the UFO is hooked over the top of the module. Obviously, that's what's going to hold the module in place. So if it, pops off of there when you're tightening it down, loosen it back up and make sure it's catching on to the module. Torque it to 80-inch foot-pound or 80-inch pounds. Sorry. You're going to go ahead and then you've got your first rail kind of squared up in place. Now you can go ahead and secure your next modules. Before you set the next rail down, go ahead and put your UFO, your universal fastening object, into place. And then you're going to slide the second module up against that UFO. And you're going to torque it. And you're going to repeat it for each following module. So you'll slide it in, or put your UFOs in, slide your panel down, put another, tighten it down, put your other UFO in, keep sliding panels in. Probably just take a couple guys. I know yesterday we were out putting up some panels. We were actually on a roof mount yesterday, but it really wasn't super windy, but it was a little bit. And I guess I've never really been up on a roof when it's got a little bit of wind and you're moving those panels around. We had 2 guys on a lift and 2 guys on the roof. And that made it really nice because there were times when that wind picked up and you could definitely feel like you were going to be sucked off that roof if it was you by yourself. So it's best to have on a roof at least 1 person on a lift, if you're handing up the panels, and 2 people on the roof. It just makes it a lot more safe and secure. So just little things that I see when I'm out in the field doing stuff that I like to mention.
Hey, I'm going to throw in something on that too. So the one thing that I usually like to do, but I see why Iron Rich recommends starting at the bottom corner, I like to start in the middle. Usually have to do 2 panels while you're starting in the middle point. It's a lot more measuring, but my thought is just from experience, that if you start in the very middle, so you have a lot more measuring to do and everything, but if you get off of square while you're laying panels, you can at least adjust a little bit, maybe like a 1/16 of an inch with every module you lay down. So that way, if you start in one corner and you get to the opposite corner, you could be off quite a bit if you're not consistently checking your squareness. And so that's why I like to start in the middle, because then it's only half as bad. You can kind of work it both ways. Like I said, it's more measuring and more finagling to get started, but I kind of feel like in the long run, it saves you more time if you were to not be square. And another thing, John, is, on that same regard, is that whenever you're starting, your foundation, even your posts, everything about what you do for racking affects transcends, to the next step. So if your posts aren't plumb, it's going to affect how your racking goes together. And if your racking is not square and plumb, then when you go down to lay your modules, it's going to be really bad. So everything is about foundational steps, just like you're building a house. So just to make sure that, when you're laying your panels and everything's not coming out right, it's likely because of something you did a step or 2 in front of that.
Yep. Make sure you're securing the last end. Place the last module into position on the rails, a minimum of 1 inch from the rail ends. You can kind of see the little UFOs are pointing to. Those UFOs have the stopper sleeve, so they're basically end clamps is what they turned this into instead of a mid clamp. Make sure you're torquing them to the proper specs. Secure the UFO clamp on the rails and ensure they are hooked over the top of the module. It'll have like a little ring to kind of catch that module. So make sure that they're obviously catching, because that's what holds the modules to the rail. Make sure that there's a minimum of 3/8 gap if you have rows of panels. We like to use, we'll normally use like a couple pieces of wood and make kind of a template so you can put it in between the top rail and the lower rail or the modules. And then you can slide that module that's on the lower rail up to that board, and then it gives you the same gap in between the top row and the second row all the way along your panels. It kind of speeds things up so you don't have to keep measuring in between the rows. It's just kind of a nice little thing to use, so you know that you're getting the spacing evenly between the rows. If we don't have gaps between the rows, then basically the panels or the racking system and everything becomes a great big sail. As you know, if you've ever been on a sailboat or even seen a sailboat, I'm pretty sure you know how they work. You know, it catches the wind and moves you. Well, these are like a great big sail. You know, if there's any kind of wind, if there's no gap, you know, it could definitely do some damage to the panels. So it's just like a sail. If you were to rip a hole in the sail, it's not gonna, you know, move that boat very well. Well, that's the same principle here. We want to leave that gap so we can get the air will move through there freely and not cause a big kite right there on the side of your home. So using the camo, we talked about that. This is kind of basically makes a little bit of a cleaner look. But basically, you're going to slide the camo into the rail channel far enough to clear the module frame. And it does require a 6-inch clearance from the end of the rail because it's going to spin back around and snap into the railing itself. So place the module on the rail. When installing the camo, the module can overhang the rail no more than 1/4 of an inch. You have to keep that in mind when you're putting your railing together. Basically, you're going to pull the camo towards the rail ends at a 45-degree angle. So the bonding bolt contacts the module flange edge. And you can kind of see it in that picture there to the right. Obviously, you're going to secure it to the frame. Rotate the handle with an upward motion until the camo snaps into the rail channel. So you can kind of see in that bottom picture how the camo end is kind of tapered, and that will snap into the channel. Ensure the camo bonding pins are fully seated on top of the module frame. You don't have to use the camos, but they will give a cleaner look. You can also use, excuse me, the UFOs as well. Diagonal braces, these are optional. Basically, how it's going to work is you're going to slide the sleeve on the north pier about 2 to 3 inches above the ground, or 6 inches max. So on the longer pier, you're going to be lower than your shorter pier. So your north-south pier. Attach the diagonal brace with to the sleeve. You've got a 1/2 inch hardware there you're going to use. Slide the second sleeve on the south pier 2 to 3 inches below the top cap, 6 inch maximum. Then you're going to raise the diagonal brace to align the holes in the sleeve and brace. Attach the hardware, and then you're going to raise the sleeve to its full extent. Go ahead and torque those down to the listed values, and that'll give you your diagonal bracing. You got more wind or snow load or something like that, and that's when you would need this diagonal bracing. End caps, they're not required, but they give the install a completed look. They will keep any kind of debris or hornets or anything from mud daubers or anything like that from building nests inside of there. Basically, you're just going to press the end cap into the rail. They come in a set of left to right, so check that you have the proper end caps. They do come with it. So again, if you lose them or something like that, it's not the end of the world. We can get you some more if you would like. I would recommend putting them in just basically to keep the bugs and stuff from getting inside of there and building nests. If you have an open structure installation, You can also use adhesive to secure the end caps to the railing itself. Wire clips, wire management. You're gonna have to. We've got to make sure we're not just having wires hanging around. We want to make the job look professional, and we want to again make sure those wires aren't flopping around. Obviously, if the wires can move around, then they can rub on the metal, and then you get a the insulation is compromised, and you could cause some issues with your panels, grounding them out, shorting them out, things like that. So wire management is important. We have wire clips for simple wire management. Basically, you're just going to press them into the rail. And then once you get the wires into the clamp, there's actually a little tab on there, and you can press it in, and it'll lock it in there. Real easy to take back out if you need to run more wiring in there. You could use zip ties. Over time, those zip ties are going to fail, though, because they're not really meant to be out in the weather and in the sun, so they will have a tendency over time to get brittle and break. So we would recommend the wire clips. Splicing cross pipe. Obviously, follow the instructions when required to join one section of cross pipe together to ensure bonding is maintained throughout the system. Basically, we have the splice tube. It's a 6-inch into the first section of your cross pipe, and you're going to secure it with self-tapping screws. Spaced at approximately 1.25 inches from the end of the pipe and approximately 3.5 inches apart, and tighten those appropriately. You're going to go ahead and slide the second section of cross pipe over the splice tube and secure with 2 more self-tapping screws. So you can see on the right, if this is one big pipe here, you've got your internal splice, your cross pipe here, and you're going to put the 4 screws, 2 on each side, to secure that. You can also use, on the Schedule 40 pipe splice, you can use the galvanized threaded pipe coupling that match the proper size used for the structure. Threaded Schedule 40 grade B pipe must be used when splicing cross pipe together. So basically, you're going to fully thread the coupling on both sections of the pipe, just like you would for when you're normally joining pipe together. It's just a standard coupling. Make sure it's threaded all the way on there, and it nice and tight on there. Grounding. Make sure we're always grounding the rack. Okay, so let's say you have on the ground mount, you have 3 racks. You may want to ground those together. You're gonna have to ground all 3 of those racks, so you can bond them all together. We have splice jumpers, weaves here in the picture, but we've got to make sure we've got proper ground. There are also on the inverters, there are some lightning arresters, and we want to make sure we're always installing a lightning rod in the circuit as well. So, you're going to have to drive a copper grounding rod into the ground if you don't already have one. We've got to have that. That's a definite must. Any comments on the lightning arresters or anything, Kyle? I guess not.
Sorry. I had to unmute myself, and then I couldn't get my mouse to do what I wanted. Not really. I mean, so you have lightning protection, and then you have grounding protection. I'll call as a separate thing for your electronics. Basically, the grounding side of it, I recommend a lightning rod separate from the ground rack to the straight to the ground. So a secondary lightning protection. Now, as everybody knows, I'm no electrician, but you know, I've heard two different thought theories that you have, you know, the ground rack is your ground. Well, if it's struck by lightning, I don't think that it is. And so that's why, I mean, for the low price of what a ground rod is, I recommend that that we make sure to go ahead and do a secondary ground, I guess we'll call it, and take the rack and put it straight to a ground rod. That would be that comment on that. And lightning arresters we sell on the inverters. If on microinverters we only do a AC lightning arrestor, and then on string inverters, including SolarEdge, we suggest a DC and an AC lightning arrestor. We've seen this even regulate voltage from the utilities a hair, and that can help with that. And then it also is just a nice little comforty feeling for lightning protection as well as warranty protection if it should ever be an issue from the inverter manufacturer. So that would be, I think that would be my only other comments.
And basically those lightning arresters are almost like a sacrificial lamb. They're supposed to take the lightning and save the other portions of your equipment. So that's what, if they're gonna fail, but that's what they're there for. They're supposed to absorb it, basically.
And they're one, and I mean, you can, I guess you can get other types, or it would be a surge protector at that point, but the lightning arresters are a one and done. So once they're zapped, they're gone.
Yeah. So this is a little bit of some racking here. This is more, we're not using, it doesn't look like this is the actual Iron Ridge. This may be the preferred or performed pipe product here that we're going to look at next. But this is a ground mount. It's actually out of Kyle's barn there. But you can kind of see the racking, how it's kind of going up. Here's some more pictures, a little bit better picture. You can see the strong backs there. We're using I-beams that were pounded into the ground. Again, be real careful when you're doing that, that you don't, if you hit a rock, it's going to bend that post. So that's the only thing that can be a little bit problematic with the pounding of the posts there. But just some pictures. You can see you've got two rows of panels here on the ground, and there's basically they're driving that post into the ground.
On ground mount, or on ground mount, on the single post row, that's what I you know, that's what we kind of call a single post row here with this I-beam. There's I-beams, and then there's single pile or C piles, and we really like the I-beam. It's much more meaty. It can handle a rock, and it can push, you know, break apart some rock. Whereas a C pile, which would be, for example, not picking on anybody, but a Unirack pile, for example, the C pile is pretty flexible, and even in clay, they can be busted and lose their C shape, and they'll turn into a spoon. So at that point, they just kind of go wherever they want to go while you're pounding them in, and it's really easy to lose your squareness, I guess I'll say. And whereas I-beams are a lot more rigid and stronger and can take a lot more of a beating. And so that's why we like the DPW Perform Line product, and as well as we're looking at the advanced racking product, because they have an I-beam post as well. So we're just trying to stay away from the C pile style, but you never know because costs affect different things. So it just depends on where you're at, how much rock you have to go through, and what your soil conditions are.
So this is the Perform Line product. You can see the I-beams and which are called basically your strong back there. And then it's got some diagonal. So basically on this, it doesn't have you've got 4 posts instead of 8 like the Iron Ridge. Iron Ridge would have 8 in this because it had 4 in the front and 4 in the back. On this Perform line product, it's just using basically a single post row, basically.
Yeah,
some of the required tools are very similar.
Sorry,
what's that?
It's like that cantilever out the front, and so you only have so many. It's a little nicer to mow around and take care of underneath, and everybody loves this style to install. Super fast, and complete adjustability. So John's going to explain more about that now. So sorry to interrupt, John. Go ahead.
Again, it's going to take some the similar tools to Ridge, but you're going to have a 1/2 inch socket for 5/16. Module clamp hardware, a 5/16 wrench or socket for 5/8 hardware, torque wrench, a ratchet, extension bar, a string, a frame square, a tape measure, and an inclinometer. Quick note that it is stainless steel hardware and it can gall when tightened too quickly. So the installer should use a silver grade anti-seize compound prior to assembling the hardware, and do not use an impact driver. You can use other drivers, but they should be set to the low speed setting. Just if you over tighten them, it has a tendency to cause some issues. So make sure you're not over tightening.
This would be on your mid clamps and end clamps,
right?
Things like that. And then let's see if I can do it. Inclinometer. Man, I can't do it either. Anyways, you can get an app on your phone to get you rough numbers. And as long as you're within, I believe, John, it's 3 degrees.
Yeah, we'll cover
that. You can use that, but it's really best to, I don't care if you go on Amazon or wherever, but get a real one, and so that tells you exact angle of what you're dealing with. So just a suggestion there.
So PLP, so that's the preferred line product, or performed, I'm sorry, performed line product. They use PowerPeak AL ground mount system. It's basically designed to mount on standard I-beams, which are commonly pile driven directly into the soil. Definitely reduces labor costs and saves a lot of backs. I know everybody loves the good old post hole digger. Good stuff. So with the PowerPeak AL, you can actually drive the I-beams in. They're designed for specific site conditions, and it will arrive on site with fewer pre-assembled components for a simpler and faster assembly. In the design phase, the entire array is selectively broken down into individual structures. So each individual PowerPeak structure mounts the modules 2 rows in portrait, where the number of modules in each row matches the specified string size, and it just basically makes it a lot easier for wiring and obviously less materials. The PowerPeak mounting system, it also has a lock-in-place clamping system for fast and secure installation. We'll cover that here in just a few minutes. The I-beam size and foundation requirements are obviously based on several factors. Array surface area, maximum design wind speed, snow load, tilt, soil type, front edge clearance. So there's quite a bit that goes into designing a rack. I mean, you just don't want to just throw something up there and say, hey, yeah, this looks good. There are a lot more things that we have to take into consideration when we're designing this racking system, and for any racking system for that matter. The I-beam max span is 150 inches. You can make a 35-inch cantilever with the outside posts. Is that something maybe you want to expand on
Yep.
a little bit, Kyle?
Yeah, I added these last 2 points in. So by spec, this company allows us to span between posts 150 inches. So then, so we have, in between, we can go that far apart. It's kind of nicer to go a little bit narrower, but on that earlier slide, and we don't have to go to it, but we had a kind of a CAD image of what that looks like, and that was actually a 26 module array, and that is maxed out at the span between each post. So that is literally like 148 to 150 inches between each I-beam. And then while you're on that slide, the cantilever that was referenced is from the last post on the left and then the right, and that allows us to stick the post inside the module edge 35 inches in. So that's just post placement, and that's what is best for the array, so that you don't have to use as many posts as what you would think. Because if you would have, for example, taken these posts and put them on the outside edge, your spans would have been further apart, requiring you to have 5 posts in this case, and more material cost, possibly even more labor cost. I mean, I guess obviously it would add more labor cost, but so that's what I was, wanted to throw in there on the placement of posts. And then so you can figure up your inches between each post by your gaps. So we have 3 gaps here in between each. So we're just that would, by the number of modules that we have divided by 2, obviously, because we're stacked up and down, we would actually be able to take our total inches of the array and be able to come up with a pretty quick calculation on how far apart our posts need to be placed.
So the main components of this PowerPeak AL, so we've got your I-beam there, obviously, which is considered your strong back. You've got your strong back attachment. You've got your rails, your strong back assembly. You can kind of see the cantilever down there as well, where it's got your strut attachment assembly. You have bonding clamps. And again, make sure that you're putting your grounding block, let's say, anywhere in the railing as well. I know the one we did yesterday, we put it underneath. We're on a roof, obviously, but still we have the grounding block. And we put it right by the last panel where the wires go through the roof down to the inverter. We put it in the rail close to there, so you don't have to run wire quite as far. So in the Iron Ridge, we talked about the UFOs, or basically holding the modules down to the racking. With PowerPeak, they use these 2 clamps. The one on the left is a mid clamp or a bonding clamp. So if you have 2 panels, it'll go in between the 2. If it's on an end, it's the last panel in a row, then you have your end clamp. So there's 2 different clamps, or it could be on the bottom of the panel too. If there's nothing below it, you need to put one there. These are just that, end clamps. Anytime you have 2 panels together, then we will use the mid clamp. Basically, the first thing you're going to do is you're going to set your I-beam posts using the preferred method, whatever that may be for you. Make sure you've got the height of all the posts that you have, or the I-beams, within about 1/4 inch of each other. The next thing you're going to do is you're going to install the strong back attachment to the I-beam. You're going to use the 5/8" hex bolts and your nuts and your washers, and there's slots for the strong back attachment. Obviously, you're going to just hand tighten those bolts for now. The strong back attachments must be consistently installed on the same side of the I-beam. So it doesn't matter which side per se, but it needs to be the same for, if you've got 4 I-beams, it needs to be the same for all 4. So if they're all on the east side, that's fine, or all on the west side, just make sure that they're all on the same side of the I-beam. You know, the left or right side, or the east or west side, however you want to look at it. Install the strut attachment on the I-beam. Make sure you're installing it with the knob pointing upwards, and you're going to have a mark on your pipe there. Basically, the vertical position of the strut attachment on the I-beam determines the tilt angle of the array. So therefore, you must the position must be measured and marked on each individual I-beam, so you have the same angle. You know, whether that's 10%, 30%, whatever that may be, but it's got to be the same for all of them, obviously. So you're gonna have to mark, if you've got 4 I-beams, make sure you're marking all 4 on the same spot on the vertical I-beam. Next, you're gonna install the strong back using the proper bolts and washers and nuts, and just hand tighten it for now. Install the strut to the strut attachment and hand tighten that. That's probably going to be a 2-person activity. 1 person can hold the strong back pre-assembly in place, and the second person will line it at the attachment points and secure it with the hardware. It'll make it a little bit easier if you're not trying to do this by yourself. It's not really heavy, it's more bulky and awkward, I should say. Align the rail base surfaces via the strong back. So pull a string on top and between the east and west most strong backs. Align the string with the center of the I-beam. Next, on the strong backs that need adjustment, you can loosen them and slide them up or down to bring the strong backs within an eighth inch of that string. To adjust the north-south alignment of the rail bases, make sure you're getting those all adjusted properly, and then tighten them to the proper torque value. Then go ahead and tighten your strong back attachment securely to the I-beam. It's very important to align the rail base surfaces within about an eighth inch of each other before installing the rails. So you can loosen the strong back attachment here on the left lower to level for one another. So it'll give you a little bit of room to align it. And then the strong backs, you loosen them and they'll slide north-south adjustment. Verify and set the final tilt angle. So here's that word again. Inclinometer, that's what I'm gonna go with. Place the inclinometer on the strong back, loosen the hardware, securing the strut attachment to the I-beam, and then slide the strut attachment up or down the I-beam to bring the tilt to the desired angle. And then retighten your strut attachment to the I-beam. It's probably gonna be best if, again, if you have 2 people, 1 person to hold the southern end of the strong back while the second person loosens the hardware and then retightens it once you've gotten your desired tilt. The inclinometer variance between the strong backs must be set within a 3-degree tolerance. So they all got to be within 3 degrees of each other. It shouldn't really be that difficult to get. Installing the rails. The rails are secured via the pre-assembled clamping system. So it's got a rail base and rail clamp, which are attached to the strong backs. The cantilever distance between the outermost strong back and the rail must be set per specs. So you can kind of see that little rail lip under the catch base of the rail on the left side there.
Can I interrupt on that one, John? There on the last slide and this slide, so you have your rail clip there. I do not recommend moving any points out of factory settings unless you have to. Meaning that you can get yourself all out of whack really easy if you just start sliding stuff around, because basically there's tons of adjustability with this system, which is awesome. However, you can get yourself into a lot of trouble, and I know this is minor trouble, but you can start moving too much and spend your whole day trying to bring back that racking back to where it was at factory. So that little clamp there, that with the red arrow on the left, that clamp is intended not to be moved. It has a red, very strong Loctite on those pieces, and they are not intended to actually go, to be moved at all. And then the other points on the other slide are where you're wanting to make your adjustments. But what I'm just cautioning is don't make any more adjustments or do calculated adjustments to where you're not making moves and then having to recover from that.
Yeah.
Just speaking from experience. And I think, on a 40 module job, if you don't get crazy with it, I think you can easily put the racking together. If the posts are already there, you can assemble the racking in about an hour and a half with 2 people. So just to give you a judge of how long it should take.
Splicing, if you need to splice 2 rails together, definitely can be done. You've got to have the splice plate and the self-tapping hardware, and it can be done either before or after the rails are installed on the strong backs. I would probably do it before, just from experience, but that's totally up to you. It's not really that difficult. It's pretty self-explanatory. You'll use some self-tapping screws and just put the splicer plates on the railing themselves and attach it. Again, this is what Kyle was just talking about. The location of the rail bases are preset at the factory. If alignment with the rails is a problem, you can slide the rail bases along the strong back to align with the rails. And again, if you got splice plates installed, and you've installed them prior to the rails, you may want to use 3 people because it's going to be really long. And we don't want to pick up on the ends and then have that splice plate kind of flex there in the middle, because it could damage that splice plate. So if you're going to splice it, as before it's onto the rails, make sure that you use 3 people to do that. Square the rack. The adjustments can be made to compensate for misaligned I-beams or other issues. You can see the hardware. It should only be hand tight right now anyway. So once you get it kind of aligned up, you can definitely tighten that back down. But during the squaring and alignment process, the main adjustment feature is the east-west articulation of the strong back via those mounts there. You can actually pivot that thing up to about 5 degrees east or west. And basically we're using that so we can get them squared up to the rails themselves. So again, there's about a 5 degree movement that you can get out of that. So if it's way far out of alignment, I mean, we can't do anything about that. But if it's a little bit out, we can definitely have ways to compensate for that.
It will happen. You will get out of alignment. Like we talked about rocks in the soil earlier, like or the way that the pounder just happens to be hitting the I-beam in this case. It's basically because the I-beam twisted, or something like that. But there's quite a bit of play with those strong backs to be able to bring that back to square. So it's just a little bit, once you actually get everything put in place, then you come back and tighten everything down to lock it in place. Another thing I'd recommend to prevent that twisting or to be able to see that is whenever you're putting the posts in, use two strings, and one at the top and one at the bottom, to be able to line up the post just from, so you can see that the post is going in square.
Thanks, Kyle. Make sure you're tight. You always tighten and torque the hardware. I'm not going to get real again into your torque values because I don't expect you to remember that. But it is extremely important to tighten and torque all the hardware as specified. Exceeding torque values can result in damage to the components. So again, we kind of talked about that when we first started into this. Is we've got those stainless steel, hardware, and you can gall it. So make sure we're not over tightening things, and we're not under tightening as well. Next, we're going to install the modules. It's really easy with this rail system. Again, we have mid clamps and end clamps we talked about. On the left side is a clamp. You got module on each side. And you can see on that module in the middle of that little clamp, that orange clamp there, it has like that. You've got the two nipples on the outside and then the shorter one in the middle. There shouldn't be any gap between your panels. It should sit in there real snugly. You can see on the right side, you've got a gap, and we don't want that. We also want to make sure that the plate, that orange part you see, is sitting flush onto both of those panels. If they're raised up or anything, you could have starting to get some waving going on or something on your rails, but want to make sure it's flat and there's no gap. So no visible gap between the bonding mid clamps and the module frame. This is the end clamp, and you can see we want the end clamp pushed all the way up against the module so that there's no gap in between basically the bolt and the module. So no gap. And then a lot of times when you tighten these down, at the very end, they'll kind of spin just a little bit, so it's not real square. It's not really going to hurt anything really too much. We like to just take a hammer and tap on that orange backside to kind of square up the face of that plate, just to make it look a little bit better. And you'll get a better grab onto the module as well. I'm not saying you got to take a hammer and hit it real hard, but you just tap it back into square it up a little bit. Again, no visible gap between the neoprene washer and the module frame itself. Installing the modules. Prepare to install the modules by first marking the rails, usually about 1.5 inches from their ends, as indicated above. The end clamps will align to these marks. Basically, your last panel is going to go up to that mark, and your end clamp will be right there. Again, you can torque your to the proper values as well. So you can see these are basically your mid and end clamps. It's got a little T-bolt on it that'll slide into the rail and then spin, and that'll lock it into the channel itself. And again, you can see just a picture. Obviously, we don't have another rail behind this one. So this is our end clamp. And again, minimum 1.5 inches in between that end clamp and the outside of the rail. Mid clamps are just that. They go in the middle of the panel. On a panel, you'll probably, you just have on the long side, in the middle, you just have one clamp on each side of the long side there. Make sure you have a grounding or a bonding path. So this is the grounding path of the racking system here. Just kind of showing you what's going on. You've got it's pre-assembled underflanged Perlin type mid clamp. or we've got the weed lug over on the upper right portion. And again, you can just kind of see the grounding path. And here it's using number 8 or number 6 wire to the grounding rod. Grounding lug, again, it's got the T-bolt on it as well. It'll just slide right into the rail, and it can go into the railing anywhere. It doesn't really matter. There is a little, you've got the grounding block, and then there's a little metal plate underneath there as well. It has some little nipples kind of sticking out that kind of attach to the metal a little bit better. Make sure that you don't lose that when you're installing it onto the railing itself. Make sure you're always using that lock washer as well. Sometimes they tend to want to slide off and fall, and make sure you don't lose that locking washer as well. We recommend solid or stranded copper conductor, and they're using 14-6 AUG wire, solid or copper, or solid or stranded copper wire, not aluminum. I just wanted to touch base real quick. This is another racking system that's very similar to the one we just looked at. The only thing really different is the brackets that they're using in the rail. So they're still using an I-beam. They've got the strong back. Basically, we're not going to really get into the advanced racking today. It's one of our newer products. So going forward, we'll have more information on it. But right now, I just kind of wanted you to see, you know, there's so much racking out there. There's so many modules. There's, you know, inverters. So there's, if you see something that you like, that, you know, that maybe we have and trained on or something, you know, let us know. But I don't want to cover every single racking system and confuse you too much. So today we just kind of started with the 2 on the ground that we will use the most often. And you guys probably will too, but know that there's other racking out there. I mean, if there's something you see that you like better, you know, let us know. We'll look into it. You can definitely use it. You know, just let us know, and if you would, you know, we'll kind of go from there. But I don't want to cover every single racking system and really kind of get you like, wow, there's so much going on. But so that is the racking system on the ground. It'll probably take you a little bit longer, obviously, on your first install, but as you get, you know, doing it more and more, it'll definitely be a lot easier. I know yesterday was one of my first really racking jobs that I've been on, so it's kind of nice to see, you know, how they get it all squared up and how they, you know, make sure that it's aligned properly on the rails. So it was good to definitely get out there. If you got a chance to go out and look at a job, if you want some pictures, you know, definitely give us a shout. But that's what we have for today. Next week, next Wednesday, will be some roof mounting. So we'll cover quite a bit of that. Railless or railed racking. So it'll probably be about the same length, maybe a tiny bit longer. There's a little bit more information in it, but we'll hang out for a little bit here and answer some of your questions. So again, thank you for your time, and stay safe out there, stay healthy, and give me a shout if you need anything.
Thanks, John. I'll throw in, well, some folks are typing questions. I'll throw in some more comments on brands of racking and why we do what we do. Iron Ridge is that, you know, it's just about, it's a strategy, and shipping is the biggest issue with racking. You know, it's really, it's metal, it's a relatively low cost item, and or material rather. The problem though with racking is shipping, and so it just depends, and as well as your trucks. As we found out, you know, yesterday, we thought we had everything we needed, and we had to run back to Intertech a couple times because we didn't have everything on our truck that we needed, and we were joking around and said, all right, that's enough. We're buying a cover trailer, and we're going to have a full system in here in case we, you know, have adjustments. And of course we're kidding, but my point is that staying consistent with a racking company is good for everyone.
Yes.
So, you know, that way, whenever you go to do different types of jobs, you at least have extras around for what could happen on the job. You know, your racking, your layout may change while you're on the job. A ground mount likely won't, but a roof mount stands a really good chance of changing. But as far as it relates to the products that we sell, you know, DPW is a product that's great, but you really want to look at that and more volume. It's really fast and it's really quick with labor, but it's got, you know, the more that you move for in volume with that product, you save on labor, but then your shipping costs can kind of eat you up on that one. Now, whereas Iron Ridge has a little bit more labor time involved, however, it can be bundled up in a really small stick, essentially, for shipment that makes it a lot cheaper on the shipping side. And last, why we're so brief on advanced racking is because it's an I-beam post, and we're scratching the surface with our company to make sure it's a good fit for Intertech and our customers. But it's going to provide a low-cost I-beam single post row option, but that's going to increase labor. So I guess, you know, how do you want to select your racking style? Just depends on many factors, and that's why we offer so many styles and different options. But yet we do try to stay consolidated, and if we do make a move, there's a lot of strategy to it. I guess what I'd like to add on that.
We have one question, Kyle. We had a couple questions, but first one here, Rob Dirksen asked, if we see, he said he sees the use of helical piles in Michigan as a ground mount method, and have we explored this method?
Scratching the surface on it. Don't with all industries, you know how many different products there are out there, and different things to do, and different ways to adapt, I guess I'll say, and install. And helical is relatively new, but it's a screw. It's a ground screw. You know, you're essentially going to take a skid steer, likely, and you're going to adapt a auger attachment for a skid steer, and then you can put these helical screws in. So no concrete, no piling, and you can use, you can look on Facebook Marketplace or something and buy a attachment for a skid steer for an auger. But what I do see about those, and this is my opinion, is that they never really come out straight. So it seems like you're going to pay for it somehow. Like I said, it's just my opinion, but it seems like you're going to pay for the labor somehow to either straighten your post back up from the helical install, because it likely won't go in straight. The ones that I've seen aren't nearly as straight as what you can control with doing them in concrete or pounding them in. So we're kind of keeping a close eye on them and learning more, but we just haven't, we haven't even stuck our little toe in the water with those yet, just because we're watching.
And then another question, Kyle, how deep is the I-beam into the ground?
That's a swell question. Those posts, we usually look for about a 15-foot I-beam. So 15 feet tall, whenever you put it in there. You can cut the orders to size on specific jobs. If you can save 3 feet or something like that cutting off an I-beam on a bigger, massive job, that might save you something. However, the posts that we all get are either 14 feet 10 inches or 15 feet even. And the reason why I guess that question may can't come up is it just depends on how you're installing the mount itself. If you're driving it into clay, It's great because you can send it down right where you want it to be, and you have plenty of wind protection, I guess, from down pressure and uplift. And then if you're going into rock, you may or may not be able to get the I-beam post down as far as you want, but I mean, you got a good 6 inches or a foot into the rock. You can actually cut off that I-beam off the top and then drill holes through the I-beam to get it back to where it needed to be. So it just adds a lot of versatility for installation complexity.
So in other words, it's going to vary depending on a lot of factors.
Right. Yep. Clay, we're looking.
I mean, yeah, we would prefer, I would think, that it's in the ground 3 feet at least, but that's just my guess. But
on I-beams, you're looking 6 to 7.
6 feet
to 7. If there's a couple of different ways to do the I-beam installs, you can, let's see here, you can do a narrow auger. I'll call it a narrow in diameter. Do like a 9-inch or 9 to 12-inch auger. You set the post in you can auger out as far as you can. Usually you're only going to get that 4 feet deep probably. But what you can do is drop your post in there and then use your skid steer to push down the post 1 to 2 feet. That'll get it set where you want it, and then you can come back and do your concrete around that top 4 foot. That's going to get you a little bit of height out of the ground, but you're pretty set, and you're able to handle that the wind load. Another option would be to auger out a 24-inch hole 4 to 6 feet down, and you can use actually even a sono tube out the top of it to even raise the array up off the ground a little bit. And we have some customers that do that, and to basically offer an option so that it's easier to mow underneath ground mounts, and that it's easier to weed eat underneath of them, because if you have an I-beam pocket and you're trying to get weeds cut out of there, your weed eater is going to get eaten up. So having a nice wide base and jacking up the array is also an option.
All right, I think that's all the questions we have for now. Something pops up, guys, and you got more questions, shoot us an email or give us a call. Again, this webinar is recorded, so it'll take a little bit of time, but it'll probably be downloaded to our YouTube later on this afternoon. So if you need to check it out again, or you want to check out the past webinars we've had, you can go to intertechuniversity.com, click on the online video library, or you can just go directly to YouTube and look for Intertech University. That's our channel on YouTube. So thanks for joining us today, and we look forward to training you guys again next week. And have a great week and stay safe, everyone.